All right, so we are foregoing the quiz today because I was having quizzes issues. So it's coming on Monday, all right? Now, let's see, today's Friday. On Wednesday, we did page 74. Your test on Tuesday only goes up to page 74, all right? You're going to have the quiz on Monday. Listen. And then your test only goes up to page 74. I didn't want to review today and test on Monday because Monday tests are always a disaster. So we're going to go ahead and start the first thing in the next unit, but this is not going to be on the test, right? What you have, one of the things that you have is the Greek alphabet. So if you will take that and cut it in half, and you're going to put it on pages 75 and 76 in your ISN. They should be side-by-side pages. Y'all may want to go grab extra scissors back there. I didn't put any extra on that table. But the Greek alphabet is something it is important for you to be familiar with, okay? You were introduced to pi long time ago. You're introduced to theta in geometry, and then in chemistry you were introduced to a few more, and in physics a few more than that. You were also introduced to delta either in Algebra 1, which is where you should have been introduced to it, or geometry. But either way, we use a ton of these in pre-cal. You will use a ton of these in your advanced math and science classes, so you need to be familiar with it. In college, depending on what classes you take, you may even have a professor that makes you memorize it, right? So one way to memorize things or help you memorize things is with either some sort of mnemonic or like a little song, right? Like your own alphabet that you learned that, you know, maybe probably even before you went to kindergarten, you sing your ABCs, right? And the ABC song that you know goes to what tune? What's the other tune for that? Twinkle, Twinkle, Little Star. Okay. Yeah. Think about it. Did we just blow your mind? Whoa, we just blew Kendall's mind there. Okay. So now you're going to get the Greek alphabet to the same tune. And if you ever do have to memorize it, then you can memorize it to the same song. And I'll send it to you in a reminder. It'll be your little earworm for the weekend. And we'll see if you can learn it.
Alpha, beta, gamma, rays, delta, epsilon, hey, 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 zeta, eta, theta, iota, then there's kappa and lambda, mu and u and xi, xi, omicron, and then there's pi, o, rho and sigma and tau 2, upsilon, it starts with U. Phi and chi and psi are fun. Omega, and then you're done. Learn all that and then you're set. That's the whole Greek alphabet.
Okay, your Greek alphabet you have in front of you says phi for pronunciation. On here it said phi, and you know sometimes there's different ways to pronounce things. That doesn't mean you can pronounce it however you want. That's what somebody said third period. No, just like a tomato thing, right? But there's that. So if you need to refer to it, it tells you a little bit about the Greek alphabet. They are used as constants and variables, and they're universal. Okay, so it's not any works for everything. Ooh. All right, so let's look at the notes for today then. This is going on page 77. 77, because 75 and 76 is the Greek alphabet. All right, so most of this is a review, but in geometry you only learned the first 3 trigonometric ratios, but we use all 6 in pre-cal and beyond. So, but if you can do the first 3, you can do all 6 of them. It's no big deal. All right, so trigonometry is the study of the relationships among sides and angle measures in triangles. A trigonometric ratio, what does the word ratio make you think of? Fraction. A trigonometric ratio compares the lengths of 2 sides with respect to an acute angle. And that's 2 sides in the same triangle instead of comparing triangle to triangle. And then a trigonometric function is a rule defined by the trigonometric ratios. So sine is a trigonometric function. It's also a trigonometric ratio. And the words are sine, cosine, and tangent. It is not sin, cos, and tan. That is just how you abbreviate them. And then their reciprocals are cosecant, secant, and cotangent. And then this is how they are abbreviated. So in order for us to remember how to do the ratios, what's the little acronym we use? SOHCAHTOA. Good. SOHCAHTOA. SOHCAHTOA. And then we always label our triangle according to the acute angle that we are using. So that's the opposite. Hypotenuse is across from the right angle, and then the adjacent side. Okay? All right, so let's look at what we know and then what we're going to learn. We've got for sine, we know from our SOHCAHTOA here that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. That is all old news. Yes? All right. So then cosecant, secant, and cotangent are the three new ones. Cotangent is the reciprocal of tangent. Right? So if tangent is opposite over adjacent, cotangent is adjacent over opposite. So tangent being the reciprocal of cotangent makes sense with the names. Now sine and cosine are not reciprocals of each other. But when you do this, notice we have tangent and cotangent. Then you have cosine. It's not the reciprocal of cosecant. It's the reciprocal of secant. There's only one co for every pair. So secant is the reciprocal of cosine. That makes it hypotenuse over adjacent. And then cosecant is the reciprocal of sine, and that makes it hypotenuse over opposite. So each pair, the ratio and its reciprocal, there's only one co in each set of names. That makes it pretty easy to remember these. Okay? Everybody okay with that? All right, so then it says, because the cosecant, secant, and cotangent ratios are reciprocals of the sine, cosine, and tangent ratios, they are called reciprocal functions. So cosecant, what's cosecant the reciprocal of? Sine. So this would be 1 over sine theta. Secant is the reciprocal of what? Cosine. So it's 1 over cosine theta. And then cotangent is 1 over what? Tangent theta. So it's 1 over, but let's say that the cosecant of something is 5 over 3. Well, then it's not 1 over 5 over 3 to get sine. It just makes it the reciprocal, right? It makes it 3/5. So don't make it more difficult than it needs to be. All right, so then number 1. Or actually, we're going to start with number 2. Down here, they say to find the exact values of all 6 trigonometric ratios of theta. So here is theta. I'm going to label my triangle. This is the opposite side. This is the hypotenuse. This is adjacent. So when I go to find sine of theta, sine is opposite over hypotenuse, so that's going to give me 4 over 4 square root of 5. Right? And then I can reduce the 4's out, right? Does that just leave me with the square root of 5? No. Leaves me with 1 over 5 square root of 5, but then I have to do what? Rationalize, and what would I end up with? Square root of 5 over 5. Good. So then cosecant is the reciprocal of sine. Now, there's 2 things I have written here. I didn't write the in-between step, the 1 over square root of 5. But which one of these 2 do you think might be better to take the reciprocal of to get this one? The first one, exactly, because then I won't have to rationalize, right? So if I use the reduced version of this, which would be 1 over the square root of 5, then when I take the reciprocal, I just get square root of 5. Make sense? Think smarter, not harder. Don't do it again and then have to rationalize. All right, so then cosine theta is adjacent over hypotenuse, so that is 8 over 4 square root of 5. So when I just reduce it, I'm going to get 2 over the square root of 5, and then when I rationalize it, I end up with what? Good, 2 square root of 5 over 5. Secant, which is the reciprocal, if I use the 2 over square root of 5 version, then I will have square root of 5 over 2. These don't necessarily have to be boxed, but I'll be consistent. Then tangent is opposite over adjacent, so that is 4 over 8, which is what? 1/2. That's okay. I get 2 every period, that's why I ask. And then reciprocal, I get 2. Okay. Everybody okay with that? What questions do we have? Anything? All right. So let's look at number 4. I'm going to have to do this, but I only have 2 of the 3 sides. What do I need to do to find that third side? Okay, I can do Pythagorean Theorem. Okay, so we'll do 6 squared plus 6 square root of 3 squared equals h squared. 36 plus, what's 6 square root of 3 squared? It's 36 times 3, good. 108. It's equal to h squared. So then 144 equals h squared, and h equals 12. It is plus or minus 12, and then 12 is the one we actually use because the negative side length doesn't make sense. Okay. Isn't it what? Exactly. We didn't even need to do Pythagorean Theorem here, right? Because it's a special right triangle, right? And if you saw it ahead of time, that's good. And if you didn't, like, we didn't have to go through all that. If this is 6 and this is 6 squared root of 3, well, that's your s and s squared root of 3, so this has to be 2s, right? And if you recognize that, then you write down 12 and you move on, and you didn't necessarily have to do all that, okay? But if you don't recognize that, then you have to go through that stuff. So the more you can recognize and simplify things, just writing 12 there and moving on, totally fine. But you got to know your special right triangles and be comfortable with them. So good. That's one reason why in geometry, like, we did special right triangles, and then we did them and did them and did them and did them, because I wanted them to be somewhere in your brain in the long run. I know. Yeah. All right, so sine of theta. Sine is opposite over hypotenuse, so this is 6 squared root of 3 over 12. What does that reduce to? Good, square root of 3 over 2. So then the reciprocal of that, in this case, I'd go with the second one to help me with that. 2 over the square root of 3, which means I get what? 2 square root of 3 over 3. Cosine adjacent over hypotenuse, so that'll be 6 over 12, which is 1/2. And then the reciprocal is, yeah, he's redeeming himself there. Then this is 2. Tangent of theta, opposite over adjacent, so that is 6 square root of 3 over 6, which is square root of 3, bless you. Then this would be 1 over the square root of 3, square root of 3 over 3. Good. That rationalizing process should be pretty quick and painless by now. You don't want to have to take time to write it all out and do that kind of stuff. All right. What questions do we have? Anything? Good? Okay. Flip it over then. And let's look at number 5. So it says, use the given trigonometric value to find the remaining function values. So we have the tangent, right? So the tangent, we'll go ahead and fill that in. That's 7 over 24, which means I also know which one? Cotangent. 24, yes. That's my next question. You got it. Then I have to figure out the other pieces, so I need more information. So I'm going to draw and label a triangle. If this is theta, then which pieces do I know? Opposite and adjacent. So I got this is 7 and this is 24. And then I got to find the hypotenuse, right? Is this a special right triangle? No, because if it was, then one of them would be, like if this is 7, then set it to be 7 squared root of 3, or they'd be congruent, and neither one of those things is happening. So 7 squared plus 24 squared equals h squared. We get 49 plus, what's 24 squared? What does it have to end in? 6. Okay. No, don't just yell out numbers with 6 at the end.
I almost got it. Why does that end at 6?
Because if you're multiplying 24 times 24, 4 times 4 is 16. Make sense? 576. Very good. You should know your perfect squares to 25 for this very reason. It takes you forever to come up with that stuff, and you should be able to fly through this quickly. If you have ever practiced them and you just have them written down and looked at them, when you see things like that and you can think it has to end in a 6, you only have a short list of what the perfect squares are, and then you can kind of narrow it down that way. So when you add these two together, what do you get? 625. So what is h? 25. Okay, good. Okay, so if you know that one, because I wasn't going to give it away. But if you know that one is 625, then 24 squared has to be just a little bit less than that, but not a whole lot less. Does that make sense? So really what will help you, not only flashcards, but just having them written out. Write out, 1 through 25 squared, and then their answers. And if you just kind of study those numbers a little bit, they'll be in your head. You'll be able to figure them out quicker. All right, so did I even need to do Pythagorean theorem here? No, because that's what kind of numbers? It is not special right triangle, but it's a Pythagorean triple. It's one of the Pythagorean triples, 7, 24, 25. If you come up with 3 whole numbers, that's a Pythagorean triple. Now, do you have to memorize them? No. I never made you memorize them, and I never would. But if you are a number person that could remember them, knowing some of them could be helpful, because if you just knew it was 25, that'd be fine. Somebody third period asked if I could give you all a list of them, and not of every single one that exists, but of the common ones that come up that would be helpful. Yeah, and if you want to learn them, you can learn them. But yeah, the 3, 4, 5, which is also a 6, 8, 10, like any multiple of them, those help. Yeah, 3, 4, 5, I think by now we've all kind of got down. But all right, so now let's go through the rest of this. Sine of theta, opposite over hypotenuse, 7 over 25. You can go ahead and fill in the other 3 without me. Are we all good? Yes. All right, so let's look at number 8. We have the secant of theta equals 4. So secant is 4. So which other one do we know? Cosine, which would be 1/4. Okay. So then we are going to draw and label a triangle. So secant is what over what? Hypotenuse over adjacent. And this is the way I go through it in my head. I say secant, okay, secant goes with cosine, and then I just picture them with the cosine and do the opposite. Does that make sense? Instead of, like I know these I have to think of these to get them out of my brain. So it's hypotenuse over adjacent, which means the hypotenuse is 4. What would the adjacent side be? 1. Okay. So you go ahead and find the other side and fill in the rest of the chart. Why are so many people absent today? All right, we good? Almost good? Okay. Got it? Okay, so this is not right. Opposite over hypotenuse for sine. All right, so now we are going to look at trig values of special angles. These are going to become super important to you. Right now, we are just figuring out how to find them. In a couple of weeks, you're going to have to know them. And I'm going to quiz you literally every single day, at the door and in class, and possibly outside of class, until you know this thing. Because if you do not know the unit circle, you are going to struggle in everything else we do this year, and in calculus as well. All right, the people that are struggling over there have bad algebra skills and don't know their unit circle. Those are the two biggest things that are going to hold you back. Okay, so I'm going to help you get to that point. I'm not saying today you have to go home and memorize anything. Okay, I'm going to show this to you in multiple ways. I'm going to guide you through the learning process. And the people that follow me when I guide them through it, get through it just fine. The people that refuse to practice and don't think they need to, those are the people that never get it. Okay, so you don't need to freak out over it. I'm going to help you get, with ways that are going to get you to it really in your brain. All right, so angles of 30, 60, and 45 are used frequently in trigonometry. Now, just because it says trigonometry, I mean, trig is in everything. Okay, it's in pre-cal, it's in calculus, it's in physics, it's in all of your advanced math and science classes. Or not all of them, but a lot of them. So you can use your knowledge of the side relationships that we have as special right triangles. Of course, if you don't know your special right triangles either, then we got some other problems. But got our special right triangles. This is 30, so that makes this S. This is 2S, and this is S times the square root of 3. So, and then this one is L, L, and L squared root of 2. All right, so this is how we used it most of the time, because most of the time we were solving for missing sides. Another way to look at this is without the variables at all. So if I just wanted to look at it as a triangle that was labeled with 3 sides like the ones we just did, then I could relabel this and say that this is 1, this is 2, and this is the square root of 3. See how I just divided the variables out? And that makes this 1, 1, and the square root of 2. Okay? And that's the relationship. That's what happens. That's why on the front there we had the 6 square root of 3, and 12. Well, if this is 6, I double it and I get 12, and then this would be 6 times the square root of 3. And it's just basically multiply all the sides by 6. All right, so let's find all these pieces here, because these are going to be the super important numbers to you. The sine of theta. Sine of theta, and we'll start with 30. Sine of 30 is opposite over hypotenuse. That's 1/2. Cosine of 30, adjacent over hypotenuse, square root of 3 over 2. Tangent of 30, opposite over adjacent, so that's 1 over the square root of 3, which becomes what? Square root of 3 over 3. And now there's a reason I'm writing this. I'm going to mark that first one out. Not that it's wrong, it's just not the right form, but I'm going to leave it there. So then cosecant is the reciprocal of what? Sine. Cosecant is the reciprocal of sine, and so this is 2. Secant is the reciprocal of cosine, so that's 2 over the square root of 3, which is 2 square root of 3 over 3. And then when I go to do cotangent, it's the reciprocal of tangent. Well, if I use this version of it and I take that reciprocal, then it's just square root of 3. Okay? Everybody okay with all that? All right, so now let's look at 60. We're going to skip over 45 for just a minute and do the rest of this triangle. So for 60, sine is opposite over hypotenuse, so it is the square root of 3 over 2. Cosine, adjacent over hypotenuse, it is 1/2. So let's just pause right there, and do you notice anything interesting there? Yes, that the sine of 30 is the same as the cosine of 60. Cosine of 30 is the same as sine of 60. Okay, so that's going to be helpful in you remembering how to do these things moving forward as well. All right, so then tangent is going to be opposite over adjacent, so it's just the square root of 3, which is the same as the cotangent of 30. So cosecant is the reciprocal of sine, so that's 2 over the square root of 3, which is 2 square root of 3 over 3. Oh, wait, what am I doing? So since sine and cosine have switched places in 30 and 60, then cosecant and secant do as well. That should make sense, right? And then the reciprocal of the square root of 3 is 1 over the square root of 3, which is square root of 3 over 3. Okay. Everybody okay with all that? So even though, yes, you have to just be able to rattle these off, the numbers didn't change that much, right? We just have to learn how to put them in the right places. Okay? But again, you don't have to go home and memorize this right now. I'm not saying that at all. So let's look at what happens with 45. So sine of 45, opposite over hypotenuse, doesn't even matter which angle you grab, right? You're going to get 1 over the square root of 2, which becomes what? Square root of 2 over 2. Right. Cosine of theta is, again, 1 over the square root of 2, and then that's square root of 2 over 2. So the cosine and the sine of 45 have the same value. Then tangent, what's the tangent of 45? 1. There's 1 over 1. Then cosecant or reciprocal of sine, that makes it the square root of 2. And then secant would also be the square root of 2. And what would cotangent be? 1. Okay? So sine and cosine are related to each other with the angle measures and their trig values. And then 45 just kind of relates, 45 relates to itself. Okay? We good? So again, right now, you have to know how to find them, but you don't have to go memorize them. We'll get to that point. But if you flip back over to the front, look down here at number 4. So if this is a 30, 60, 90 triangle, what's this angle measure? Which one? Is this 30 or 60? 60, because it's across from the... So this is 60. So this is really sine of 60, cosine of 60, tangent of 60. Right? Because that's what we did. And if I divide each one of these by 6, I get 1, 2, square root of 3. Okay? We all good so far? Awesome. Then you go ahead and get this taped in.